Core Free Review Sheet L Integration 2. The questions on this video are not the same as those on the review sheet, but they will help you to answer it. First one, you're asked to use the substitution u equals 4x plus 1 in order to do an integral. If you're asked to use the substitution, then you must do it that method, even if you spot that you can do this directly by inspection. So, we're told u is 4x plus 1. Always, first of all, find du over dx. So differentiating du over dx is equal to 4. Now, if we treat this du over dx as if it's a fraction, then you can say that du is equal to 4 lots of dx. And that means that dx is equal to du divided by 4. So, we can replace the dx by du over d4, and we can replace the 4x plus 1 by u. That means that our integral here is going to become u to the power of 6 du over 4. I don't know why that immediately reappeared. Now, this here is du divided by 4. It's a quarter of du. It's easiest to take the quarter outside of the actual integral, leaving you with a quarter of the integral of u to the 6 du. U to the 6th goes up to u to the 7 over 7, and the quarter is there, and then that is the same as u to the 7 over 28. And so we can now rewrite it as 1 over 28, and then replace the u by 4x plus 1. You get 1 over 28, 4 plus 1 to the 7 plus c. That's the answer. Next one. Use the substitution u equals x minus 2 in order to find this integral. Again, start with du over dx. Du over dx is 1. So in this case, du equals dx. Now look at the next bit here. You've got that we know what u is, okay, but we want to find x and x plus 3. So u is x minus 2, x is u plus 2. And x plus 3 is going to be 3 more than that, so it will be u plus 5. Now we can slot everything in. The dx is replaced by du, they're the same as each other. Where we've got x, it's u plus 2. Where we've got x plus 3, it's u plus 5, and x minus 2 all squared is u squared. Now when you look at this, it doesn't look as if it's got any easier. But if we expand the numerator, then we can split up into different fractions. So we need to expand the numerator and get u squared plus 5u plus 2u plus 10. So it's u squared plus 7u plus 10 over u squared. And now the advantage of having a nice easy denominator there is we can split it up into u squared over u squared plus 7u over u squared plus 10 over u squared. And now rewriting it, u squared over u squared is 1, 7u over u squared is 7 over u, cancelling a u out, and this can be written as 10u to the minus 2. Now it's possible to integrate it straight away. The 1 goes to u. 1 over u is ln u when you integrate it, so 7 lots of it will be 7 lots of ln u. And then here it's going to be 10 u to the minus 1, but we're going to have to change the signs, because if you differentiate 10u to minus 1, you'd get minus times it. So you've got to have a minus here, so minus times minus makes the plus, and then plus c. Finally, replace the u's by x minus 2, and you're left with x minus 2 plus 7 ln of x minus 2 minus 10 lots of u to the minus 1, which is 10 over x minus 2 plus c. Now strictly, the bit after the ln should be in modulus sign, so I should probably have put a modulus sign there, a modulus sign there. But in most questions, it's not going to cause a problem if you just did brackets. Question 3. Use the substitution u equals x squared minus 4 to find the integral of x root x squared minus 4 dx. Again, start with the du over dx. It's equal to 2x. Now, this is going to really help us, because we can say du is 2x dx. And you can see here, you've got an x dx. So that is almost what's going to be replaced by du. So what I'd suggest you do here, rather than writing down what dx is let's make it so we've got a 2x dx. So put the square root bit first, and then instead of having x dx after it, we'll write 2x dx there. Now I've obviously doubled everything, so I put a half there. So half outside the integral, half times 2, those are the bits that cancel out. And now you can see you've got a 2x dx that's replaced by du, and a root of x squared minus 4 can be replaced by square root of u. So we've got a half, that becomes the square root of u, and the 2x dx becomes du. Rewrite root of u as u to the power of a half, and integrate it. Increase the power, okay, by 1, and divide by the new power. So that's going to go up to u to the 3 over 2, going up by 1, divide by 3 over 2 is multiplied by 2/3. Okay, and now a half times 2/3, the 2's cancel, and you're left with 1/3 u to the 3 over 2 plus c, and you've got two ways of writing your answer. You can just replace the u by x squared minus 4 and get 1/3 x squared minus 4 to the 3 over 2 plus c, or you might want to bring your square root back in which case you're going to get 1/3 of x squared minus 4 cubed, all square rooted, because of that part of the half bit square roots it plus c. Right, volume of revolution. Find the area under the graph y equals x squared plus 3 between x equals 0 and x equals 2. Okay, it's rotated about the x-axis through a full turn, 2 pi radians. What's the volume of the solid? So what it's saying is that this area here is being rotated around the x-axis to form a solid. Now, this is a formula you're going to use for rotation about the x-axis, but the volume of revolution is pi the integral between your two limits of y squared dx, and it literally is just slot everything in. So v is pi, the integral, the limits were 2 and 0, 2 and 0, and for y squared, well, y is x squared plus 3, so y squared is x plus 3 all squared. So we need to find this integral. Well, the easiest way to do this is just to expand the polynomial here and then integrate it. So x squared plus 3 all squared is x squared plus 3 times itself. That's x squared times x squared is x to the 4. 3 lots of x squared and another 3 lots of x squared, 6x squared, 3 3's 9. So slotting it in, v is pi, the integral between 2 and 0, of x to the 4 plus 6x plus 9 dx. Integrating it, pi, and you're going to have x to the 4 goes to x to the 5 over 5, increase the power by 1, divide by the new power. This one, 2x cubed, okay, going up to x cubed, and divide by 3, and here 9x. The limits are 2 and 0, slot the limits in and keep everything exact. Okay, try and avoid going for any approximations. 2 to the power 5 is 32, so it's 32 over 5. 2 lots of 2 cubed, 2 cubed is 8, 2 lots of it is 16, 9 2's are 18. Okay, obviously if you put 0 into this, it all goes to 0, so I can ignore that. And then just adding these up, and they come to 202 pi over 5. Don't forget the pi there. So this part comes to 202 over 5 multiplied by pi. Common mistake is to miss the pi out. Now, what is a volume if the area between y equals 3 and 6 is rotated about the y-axis? What if between here and here, and instead of rotating it about the x-axis, we were taking it about the y-axis to form a volume there? Okay, so let's have a look at that. All you do is, if it's about the y-axis, is you take this integral and it all swaps round. So you've still got your pi, you'll integrate between the limits, but instead of y squared dx, you'll have x squared dy. So you get pi, the integral, different limits, I'm going to call them c and d, of x squared dy instead. So let's have a look at it. We are told but y is x squared plus 3. Well, we don't want to find x, we want x squared. So if y is x squared plus 3, x squared is y minus 3. And then it literally slots everything in. Y minus 3 in here, and your limits 3 and 6. So v is pi, the integral between 6 and 3 of y minus 3 dy. And it's just a standard straightforward integral, so I'm going to leave you to do that on your own. So, good luck.